Good morning, students. So, today our topic is limit. Have you ever wondered how mathematicians predict a value of a function at a point which seems undefined? For example, sin x upon x and x is equal to 0. What's its value? Is it 0 by 0, or as some mathematicians say, it is 1? What is it? So predicting the value of a function at a point, that concept is limit. Let me give you an example. Imagine you are in a room, sipping your coffee, sipping your hot coffee, and you leave your coffee cup on the table and leave for some work. You come back 10 minutes later, and if I ask you after 10 minutes, what is the temperature of the coffee? You may not tell that exactly what is the temperature of the coffee, but you can certainly tell that it is less than what it was. Certainly, the coffee has cooled down. And you know one more thing, certainly, that if you leave a coffee for a long time, its final temperature will be room temperature. We don't know at what time it will reach the room temperature, but we know for sure that it will reach room temperature, or it will reach near that room temperature. So if we say, if we define a function pt as temperature of coffee at time t, then we can definitely say that limit t tends to infinity, Tt is 25 degrees Celsius, that is room temperature. So now let us define our term. Let us define it mathematically. Let me give you another example. For example, f(x) is equal to x square units a function whose graph is like this. That's what this is, that is x-axis and y is equal to. So now, what is the value of function at x is equal to 0? We know it's 0, but let us try to reach here with another method, like 0.1, its value will be 0.0. Value of function at 0.01, we move, that is 0.1, we move closer to 0 again, and it moves closer to 0. If we further move towards left on the number line, the value of function gets closer to 0 further. So we can see that the closer we are coming to 0, the closer of our value is to 0. That is, f0 is 0, is it? In this case, we can see it, but we are definitely seeing another phenomenon, that as x tends to 0, fx is equal to 0. We can simply see that. Mathematically, we say that as x tends to 0, fx equals 0. That's the example. We have moved from left hand side right hand side, we can similarly move from left hand side as well. Left hand side, if you move from left hand side, it will be negative, 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 and as it is square quantity, the value of function will be same. So either we move from right hand side or left hand side, the value of our function as x approaches 0 is 0. So if a point A is a real number, then as x approaches A, fx is equal to L. If then we say L is the limit of function f at A. That's how we define the limit. We write it as x tends to A, fx is equal to L. We have already given you an example that limit x tends to 0, x square to 0. Another example is limit x tends to A, c. If c is a constant, then it will be the value c. As the graph is fx is equal to c, whatever will be the value of f, whatever be the value of x, the function always retrieves the value c. Here, in this case, we have seen that is our graph. It's a curve. So, when we move from right hand side, the value of function was 0, and we move from left hand side, also that the value of function is 0. So, mathematically we write limit x tends to 0 positive fx, that is limit from right hand side, and we say it right hand limit. And limit from left hand side, taken from left hand side, that is when the approaches from left hand side, we write it, this is left hand limit. If this left hand limit is equal to right hand limit, we say limit exists. In this case, we had that, and the limit exists, and it is equal to left hand limit and right hand limit at that point. So now we have a few results that I am going to skip. One is algebra of limits. For some properties of limit, that is, let me just tell you. Limit x tends to A. We are given that limit x tends to A fx and limit x tends to A gx exists. We are given that. So limit x tends to A fx plus minus gx is equal to limit x tends to A fx plus minus limit x tends to A gx, and limit x tends to A fx into gx is equal to limit x tends to A fx into limit x tends to A gx. So these are some properties. We are gonna use them, and we are gonna use another theorem, that is Sinx theorem, and then we will go to our original question, that is what is the limit x tends to 0 sin x upon x. So this is our original question. We will return to it, but first we need to state what we say Sinx theorem. So firstly, we need to study sandwich theorem. Sandwich theorem. So this theorem simply says that we are given three functions like f, g, and h are real value functions such that fx is less than equal to gx less than equal to hx, and we are given a, and there exists a real number a such that limit x tends to a fx is L, and limit x tends to a hx is also L. So we are given, can we use that word? So we are given three functions like in that way f, g, and h. This theorem says then limit x tends to a, gx will also be L. So we are given three functions: fx, which is the smallest of them; gx is between fx and hx. Hx is the largest among them. So if at x is equal to a, limit of f and h is L, that is, this is the point L on the y-axis, then at x is equal to a, the limit of the middle function g will also be L. So this is our sandwich theorem. We are going to use it in the result. We are going to use this result to get the answer of our target equation sin x by x. So, how are we going to solve it? Let there be a unit circle with center O and there be an arc with angle x. Let this point be A, let this point be C. We join arc A and C, and we draw a perpendicular at A, that is basically tangent, which means the extended line OC at point B. So, and we also draw a perpendicular from C to D on OD. So we have CD perpendicular to OA and AB perpendicular to OA. We have these two things given. X is the angle of this sector, and OA and OC are radii of the circle. Now, clearly, area of triangle, if we see triangle OCD, this triangle OCD, it is smaller than, or let's say equal to, it is smaller than area of sector OC. Clearly, as there is this area which is greater than or equal to 0. If angle x is very small, then it may be 0, but in that case it will be an equality. So this inequality holds. Furthermore, this sector will be less than the area of triangle OAB, as obvious from here. There is another region which is more than this. So, what is the area of triangle OCA? Here CD, the perpendicular OA is the base, so base into perpendicular OA into CD. What is the area of sector? We know area of a sector of with angle theta is theta upon 2 pi into pi r square. Here theta is x, so x upon 2 pi into r is radius is OA square. And what is the area of triangle OAB? Here height is AB and base is OA. OA. As OA is greater than 0 and 1 by 2 is also greater than 0, so we get this inequality. CD is less than pi goes to pi and x into OA which is less than equal to A. So we get this we write it as equation 1. So now we will use this equation 1 source here. Now, if we see triangle OCD here, x is the angle, then sin x will be perpendicular upon hypotenuse, that is CD upon OC. And we know that OC is the radius and so is OA. We can write it as CD upon OA. So from here we get CD is equal to sin x into OA. That is our equation 2 in triangle OC. Now in triangle OAB we have, if we say 10x is perpendicular upon base, that is AB upon OA. From here we get AB equal to 10x into OA. So we are going to use 2 and 3 in 1. So CD is sin x into OA which is less than x into OA which is less than 10x into OA. Since OA is greater than or equal to 0, we can simply say so x is such that x is less than pi by 2 and greater than. We construct our circle in such a way. So sin x in this region is also greater than 0. So we can also divide sin x into OA with the entire thing. We will get 1 less than or equal to x on sin x, which will be equal to 1 upon cos x. Since x is in first quadrant from 0 to pi by 2, x is positive, sin x is positive and cos x is also positive. So if we reciprocate this inequality, we will get cos x will be less than or equal to sin x by x less than or equal to 1. So we get this inequality here. So after all this, we get cos x less than or equal to sin x by x less than or equal to 1 when x belongs to 0 to pi by 2. Now, limit x tends to 0 cos x is 1, we know that, and limit x tends to 0, 1 is also 1. And so here our f is cos x, gx is sin x by x, and hx is 1. And we have fx less than equal to gx less than equal to hx with limit of f at 0 1 and limit of h at 0 is also 1. So we can use sandwich lemma and we can simply say that limit x tends to 0 sin x by x is 1. So that is our proof. Now we started our introduction by saying that mathematicians predict the value of a function at a certain point, and we started by asking a question: what is the value of sin x by x and x is equal to 0? Is it 0 by 0? Is it 1? So we came to know that limit of sin x by x at 0 is 1. Does it mean the function at 0, the value of the function at 0 is 1? Not necessarily. So what does this limit mean? So the limit means the value of the function sin x by x is 1 in the closest neighborhood of 0. We are not certain that the value of sin x by x is 1 at 0, but we are certain that in the neighborhood of 0, the value of our function is 1. So with that, I wrap up this session. It was nice having with you all. Thank you.